Alright, we're looking at question 10. Has been determined that a 1 liter sample of water contains 125 milligrams of calcium carbonate. We want to use that to find the concentration of calcium ions per parts per million. Alright, so what we're going to do to get a parts per million is technically get the mass of just the calcium compared to the mass of that whole 1 liter of a container. Alright, so I'm going to need to start with that 125 milligrams, which I'm going to go ahead and immediately turn into grams. And 1 mole of calcium carbonate is, let's see, calcium is 40.08 grams, carbon at 12.01, and 3 oxygens. I get a molecular weight of 100.09 grams. I actually just want the mass of calcium. So 1 mole of calcium carbonate is going to give us 1 mole of calcium, and 1 mole of calcium weighs 40.08 grams. Alright, so all of that would end up giving us the mass of just the calcium from that 0.125 milligrams. Alright, now that's the mass of the calcium. Also need the mass of the solution. Now I have to actually take some approximations because it didn't really give me the weight of that 1 liter or the density of the water in that case. So I'm going to make some assumptions on here. So 1 liter is 1,000 milliliters, and water mostly weighs about 1 gram per milliliter. Now, this is a mass over mass. To turn it into a parts per million, we're going to multiply this number by 1,000,000. So let's see what we get here. We have 0.125 divided by 100.09 times 40.08. So we have a very, very small amount of calcium actually in there. I'm going to divide that by 1 times 1,000 times 1, which would be grams per liter, and get a really, really, really small number, which I will then multiply by 1,000,000. And I get that this is approximately 50.1 parts per million.